Welcome friends to the course of Marketing Research and Analysis. Thank you for participating in this course. In the last lecture we were talking about causal research and experimentation in particular, right. So, we all know that causal research means the cause and effect research, and most of the researchers in under causal is basically on the experimentation research, right. So, where you try to experiment the effect of a variable on another variable or one variable or more than one variable on some other variable, right. So, whenever we we try to see such kind of effects, we we try to conduct it through an experiment, right. So, today we will be continuing with the same lecture. So, in the last lecture we understood that the presence of a independent variable gives rise to the occurrence of a dependent variable. That means the chance of the dependent variable, the change in the value of the dependent variable happens due to the presence or absence of the independent variable, right. So, from there we continue and we understand today what are the conditions. So, what conditions are required for causality? So, the conditions for causality. So, what are the conditions that you need to keep in mind when you talk about an experimental research or a causal research? Before making causal inferences, we knew in the last class we discussed about concomitant variation. Now, what is this concomitant variation and what does it mean? Let us see this. It is a condition for inferring causality that requires that the extent to which a cause x, the x is the cause, that is the independent variable, and the effect y, which is the dependent variable, occur together or vary together. That means they move simultaneously, okay. Either they happen together or they move simultaneously, and it is predicted by the hypothesis under consideration. Example, sales and amount of advertisement. So, they vary together. So, your sales, which is the dependent variable, varies according to the amount of the independent variable, which is advertisement, right. Similarly, customer retention and service quality. So, your service quality is now the cause which decides the customer, will it retain the customer or the customer will leave the firm, right. So, these things happen together, that is why it is called a concomitant variation. Evidence pertaining to concomitant variation can be obtained in a qualitative or quantitative manner. So, quantitatively also you can check it, qualitatively. Now, for example, take this. If your car makes a funny noise, suppose you are driving a car and suddenly you find that there is a funny noise as soon as you put your foot on the accelerator. So, then you try to connect whether it is due to the accelerator or some other reason. So, to know that, what you do, you remove your foot from the accelerator to see whether the sound has remained the same or it has decreased. So, any change in the sound or no change will decide whether there is some problem with the accelerator, okay. So, what it says is, if you are when you accelerate, you might take your foot off the pedal and see whether the noise goes away. So, this is a qualitative way of understanding the concomitant variation. Now, consider this case of 1000 respondents regarding purchase of fashion clothing from department stores. So, there are 1000 people who are purchasing fashion clothing. Fashion clothing are basically clothes which are very trendy clothes, and they are sometimes costly too, right. So, the survey data is presented in the table, in the next table. So, this is the table, but before we go to that, we will see this. Respondents have been classified into high and low education groups. Now, you see high education and low education groups, and the purchase of fashion clothing is also high and low. So, there is two things, right. It suggests that the purchase of fashion clothing is influenced by education level. So, the table suggests that the purchase of fashion clothing is influenced by education level. Now, respondents with high education level, now look at this. So, respondents with a high education level, the purchase of fashion clothing is more, 73%, right. Only 27% have a low fashion clothing, purchase of fashion clothing, only 27%, but 73% have a high interest for purchasing of fashion clothes. Similarly, when the education is low, still you see the purchase of fashion clothing is 64%, which is considerably high, but yes, it is not as high as when the education is high. And on the other side, the not interested or low purchase of fashion clothing is only 36%. So, the question here comes is, based on this evidence, can you conclude that education or high education causes a high purchasing of the fashion clothing? From this table, can you conclude that high education is related with high purchase? Certainly not, right. Why? Because we have seen that low education people with low education also have sufficiently high interest in purchasing fashion clothes. All that can be said is that association makes the hypothesis more tenable, but it does not prove it. Yes, it is giving us some kind of a understanding that yes, education is related, but we cannot prove it, right. What about the effect of the other possible causal factors such as income? Because it is possible that a person, when he is educated, he has his ability to earn more also increases. So, that is why it is not education, but rather a higher income that has been resulting in the higher purchase of the fashion clothes. So, it could also be possible that a person with low education can also be earning high. So, because earning not necessarily depends on the education. So, that is why we see we cannot claim that education has a direct impact on the purchase, right. Fashion clothing can be expensive, so people with higher incomes may be more able to afford them, right. It is possible that considering a third variable, now if we take a third variable, will crystallize an association that was originally obscure or irrelevant. The time and order of the occurrence of variables provides additional insights into causality. So, in such a condition, maybe we need to take a third variable which can make our statement more effective or our experiment more fruitful, right. Similarly, time order of the occurrence. So, we say during causality, the order of occurrence of the variables also plays an important part. Now, let us see this. The time order of occurrence condition states that the causing event must occur either before or simultaneously, not after with the effect, right. It cannot occur afterwards. Rain and fall in temperature. So, when there is a rain, right, there is automatically a fall in temperature. It is not that the rain completes and then only the fall in temperature starts. It is that as soon as the rain happens, the fall in temperature starts beginning, right. So, it is either before because of the cold wind that blows, so the temperature goes down, or because of the rain the temperature goes down. So, it is either before or simultaneously, right. Gift and happiness. So, as soon as you give a gift, right, and the happiness, right. So, these two effects you can see they happen before or they happen simultaneously. By definition, an effect cannot be produced by an event that occurs after the effect has taken place, because then if it happens after, then you cannot say it has happened because of this particular cause. Okay. It is possible, however, for each event in a relationship to be both a cause and an effect of the other event. So, let us see this example. Customers who shop frequently, very frequently in a department store are more likely to have a credit card. So, if you are a regular visitor of a particular mall, for example, let us say Walmart or Big Bazaar, then you might be having a credit card for that, right, for that store. Other side, on the other way, if you see it, also customers who have a credit card of that particular store will also be having a tendency to buy more frequently. So, this is how they are connected. So, the both cause and effect are affecting each other, the event of purchasing, right. Elimination of other possible causal effects. So, when you are studying a causal causality, there you have to eliminate the other possible factors. Otherwise, if you do not eliminate them, then you cannot say that A is the cause for B, right. That means A causes B, you cannot claim it. So, to do that, in order to know sometimes what is the basic reason why something, suppose the score of a student is increasing, or what affects the score of a student. Now, we will say the amount of hard work, but to say that amount of hard work, we have to control other variables, maybe his regularity in the class, his behavior in the class and other things. So, if you cannot control other factors, then we cannot claim it is only hard work that is giving rise to better performance or lower performance, right, obviously better performance. So, the absence of other possible causal factors means that the factor or variable being investigated should be the only possible causal explanation. Example, the service quality of a travel company, the service quality may be a cause of customer retention if we can be sure that changes in all other factors affecting retention, like what, price advertising, promotional offers, product characteristics, competition, etc. were held constant. If you can hold it constant and then see whether there is any change in the retention or not, then only you can claim that service quality was responsible for retention or not possible for retention. If you cannot control these other variables, then you cannot claim it, right, and that leads to a fall in the internal validity, which I will explain later. Some of the definition and concepts which you need to understand in a causal experiment, a causal study. Independent variables. So, what are these independent variables? These are the variables that are manipulated. So, we try to change the level of these variables and see the change in the effect of the outcome or the dependent variable. So, these variables are also known as treatments. So, we have different levels of treatment, and when we change the level of the treatment, we try to see the effect on the dependent variable, right. So, may include price levels, package designs, advertising themes, let us say method of teaching, and the outcome could be the final score of the student. Similarly, test units, what are these? Individuals, organizations or other entities whose response to the independent variable or treatment is being examined. So, these are the individuals from whom we are collecting the data, for example, right. So, they may include the consumers, stores or geographical areas. Dependent variable, what is it? The effect. So, we are saying the effect. So, finally, what effect we are finding out is called the dependent variable, right, and they depend on what? The cause, which is the independent variable. So, this may be like sales, profits, market share, exam score, okay, etc. Now, what is this extraneous variable? Extraneous variables, all variables other than the independent variable that may affect the affects the response of the test units are called the extraneous variables. These variables can confound the dependent variable measures in a way that weakens or invalidates the results of the experiment. That means what? When you talked about this particular case where the service quality we were saying affects the retention. So, but if we do not understand whether the price has been constant or it has changed, because if the price also changes, then we cannot claim that it is only service quality that is responsible, but maybe the price also has an effect on the retention. So, there the price is the extraneous variable which might be having an impact on the dependent variable, which is the retention of the customer, right. Okay. So, what is it saying? Independent variable influences change in the dependent variable. Experiment. An experiment is formed when the researcher manipulates one or more independent variables and measures their effect on one or more dependent variable, while controlling for the effect of the extraneous variables. So, when you control for the extraneous variables and you check the effect of the independent variable on the dependent variable, that is when you say this experiment has been successfully covered. Okay. So, what is a design? Experimental design. It is a set of procedures specifying the test units and how these units are to be divided into homogeneous subsamples. How do you want to divide the test units so that you can make your experiment in an effective manner? What independent variables are to be manipulated or treatment are to be manipulated? Which are the independent variables and how do you want to manipulate them? That also you have to take care while making your experimental design. What are the dependent variables that need to be measured? Finally, how do you control the extraneous variables? These four things are very important. First, how do you divide your sample or the test units into homogeneous subsamples? Second, which are the independent variables you need to control or you need to manipulate? Third, what is the dependent variable you want to measure, right? Fourth, what are the variables that you want to control so that the effect of the independent variable is more clear. Okay. Now, these are some of the symbols that we will use. What is X? X is the exposure of a group to an independent variable, treatment or event. The exposure of a group means a group of respondents to an independent variable, so that we will see the effect on the dependent variable, right, of which the effects are to be determined. That is what I am saying. What is O? The process of observation or measurement of the dependent variable on the test units, the process of observation or measurement of the dependent variable. So, whatever the dependent variable the scores are, that is what you are talking about in the observation, right. What is R? the random assignment. So, you want to randomly assign, so that the more if there is no random assignment, then there is a chance of a biasness, and if there is a chance of a biasness, then the validity of the study gets weakened. Okay. So, that is why we will encourage random assignment. Okay. That means you can randomly choose the sample or randomly put in the use the variables in the study, right. So, what is the symbolic arrangement you see? Now, this is exposure, this is O1 and O2. It means that given group of test units was exposed to the treatment variable x, treatment variable is x, and the response was measured at two different points in time, let us say year 1, year 2. Okay. After giving a treatment to a group of respondents, the let us say students, let us say group of students. So, you checked the score in the first term and then the second term. Okay. Similarly, what does this mean? It means that two group of test units 1 and 2 were randomly assigned to two different treatment groups. So, treatment groups are 1 and 2. So, what are the treatment groups? The subsamples that you have divided randomly, right, and the dependent variable was measured in the two groups. So, you have measured, right, this is O1 and O2, two groups simultaneously. So, you have put in you have divided into two groups, right, x1 and x2, and randomly you have put in the treatments, right, and then measured the final result. Okay. What is this validity and why it is important? Validity, the word validity means that it is valid, as good as that. That means what? When conducting an experiment, a researcher has two goals. One, to draw valid conclusions about the effects of the independent variable. That means, I am saying that whatever outcome has happened, it is because of the independent variables that I have chosen or I have used for manipulation. So, or the treatments that I have chosen. So, to draw valid conclusions about the effects of the independent variables on the dependent variable of interest, we call it as an internal validity. So, that means in simple terms I will say that these are the independent variables and which have an effect on the dependent variable of our study. So, if yes, if this is true, that yes, these are the only independent variables which are affecting our dependent variable, then we will say we are doing good and we have a strong internal validity, right. Second is, can our study, can this study that we have made can be generalized to a larger population? That is what he is saying. To make valid generalizations to a larger population of interest is called external validity. That means what? Two things, one internal and the other is external. Internal, that means the right independent variables you have chosen which affect the dependent variable, and external validity happens when the study that you have done can be experimented or taken further, can be to a larger population, and then we can say, well, it is applicable everywhere, then it is true, there is an external validity. Okay. A measure of accuracy, internal validity, it measures whether the manipulation of the independent variables actually caused the effects on the dependent variable, right. Is the change in the dependent variable, has the change in dependent variable happened due to these independent variables or not? The accuracy level will determine the internal validity, right. If the observed effects are influenced or confounded by other variables which are called the extraneous variables, it is very difficult to draw a valid inference about the causal relationship, and then you cannot claim that yes, these treatments have resulted into the outcome. Internal validity, the basic minimum that must be present in an experiment before any conclusion about the treatment effects can be made. So, if there is no internal validity, then you cannot claim that the treatments have been responsible for the effect. Okay. Let us suppose you ran an experiment to see if mice lost weight when they exercised on a wheel. So, you put in some mice and you made to run them, right. You used good experimental practices like random samples, you chose a random sample of mice, right, and you used control variables to account for other things that might cause weight loss. So, change in diet, disease, age, etc. So, you ensured that the diet given is more or less the same, right. There is the mice are all of the similar health condition and the age is also similar to each other. So, that means what, these things are kept constant. So, we cannot say that it is due, maybe it is due to the change in diet or disease or age that has been responsible for the weight loss. So, controlling these three, we are seeing whether exercising on the wheel will it reduce the loss in weight. So, the only independent variable is exercise and the dependent variable effect is the weight loss, right. Other things we have kept constant. Okay. So, what it says is, in other words, you accounted for the confounding variables that might affect your data and your experiment has high internal validity. If you have controlled these experimental variables, the confounding variables or the extraneous variables, then you can say then there is a high internal validity. Other hand, if you fail to use random sampling, that means you randomly choose the mice group or the control variables at all, your risk of confounding is very high. That means therefore, your internal validity would be very low. You cannot claim if you do not randomly you have not selected the samples randomly or you have not been able to control the extraneous variables clearly, then you cannot claim there is an internal validity, which is a basic requirement of any experiment, external validity. So, we said it should be applicable to everywhere. A determination of whether the cause and effect relationship can be generalized. In other words, the results be generalized beyond the experimental situation, right. So, that means what we are saying, can we use this study what we have made, can it be extrapolated to the entire population? If it is yes, then we have a high external validity, if no, then poor external validity or no external validity, right. Okay. Example, fast food chains test customer preferences for new formulations of menu items in test kitchens. Can the effects measured in this environment be generalized to fast food outlets? Yes, no. If it is yes or no, if it is yes, then high external validity, if it is no, then low or no external validity, low or no external validity. Okay. Correct. So, this is what it looks like. Inside the study, internal validity, was the research done it right, and outside the study, external validity, does the same thing happen in other settings, in a lab setting or everyday setting, normal setting. So, then this is for the external validity, this is for the internal validity. Now, what are the types of extraneous variables? Let us see. The first is history. What does history mean? Specific events that are external to the experiment, but that occur at the same time. Now, that is very interesting. Now, what does it mean and how it affects? Let us see. So, it does not mean the past. History means does not mean the occurrence of events before the experiment. It does not mean it this way here. Let us take this case. The longer the time interval between observations, the greater the possibility that history will confound an experiment of this type. Let us see this example. Experiment to test the effectiveness of a new promotional campaign on the store's sale can be affected by event like general economic conditions. So, let us say you want to check the effect of the new promotional campaign on the sale of a store. Now, if you are doing it, then so whatever results come, that result could be affected maybe by the economic conditions of the country or the global economic conditions. So, if the economy is hit hard by layoffs and closings, then the results whatever you will get might not be exactly the true nature of the effect of the sales promotion on the store sales. So, this is called history. So, any variable happening at the same time and how it affects the final study. Maturation. What is maturation? So, another extraneous variable or an extraneous variable attributable to changes in the test units that occur with the passage of time. Now, what does it mean mature? You become mature with time, right. So, sometimes you become matured, your age increases, your knowledge increases. So, with the increase in knowledge, with your decrease in physical strength, your way you approach a problem also changes, right. So, let us see this. In an experiment involving people, maturation takes place as people become older, more experienced, tired, bored or uninterested, right. Examine a 2-year experiment conducted among teenagers for an acne remedy. The normal aging of test subjects is a maturation effect, right. So, it is a normal aging process which is a maturing effect, which could severely limit the researchers attempt to make sound conclusions from their findings. So, suppose you are using some kind of a some treatment, then you cannot claim that the same treatment effect, the treatment effects holds true, because with time there is a change in the maturation of the subject. So, either his age is improving, so he has learnt better way to handle his acne, or he has learnt how to effectively utilize the medicine in a better way. So, these things can also affect the extraneous variable or the the final outcome of the study, right. That is why this is also an extraneous variable. Testing effects. So, testing effect means the test effects are caused by the process of experimentation. It is the effect of a test on the scores of the second test. That means what? If I do a test now and then I do the test again, my first test, the experience will lead to an effect in the second test, right. So, typically these are the effects on the experiment of taking a measure on the dependent variable before and after. So, before is pre and after is post, pre-test and post-test of the treatment. So, there are two kinds of testing effects, one main testing effect, second interactive testing effect. Now, what does this testing effect mean, right? Let us understand. So, main testing effect means, let us say it occurs when a prior observation affects a later observation, right. Let us take this example. Consider an experiment to measure the effect of advertising on attitude towards taking a holiday in Egypt. Okay. So, what is the effect of advertising to take a holiday in Egypt? Respondents are given a pre-treatment questionnaire measuring background information and attitude towards holidaying in Egypt, right. They are then exposed to the test commercial to make, they have made a advertisement also, a test commercial, and they are exposed to the test commercial. After viewing the commercial, the respondents are again asked the same question, what is their opinion about visiting Egypt. So, the attitude might have changed, maybe earlier it was bad, now it has become better, or earlier it was very good, it has now become bad, whatever, right. So, the difference between the pre and post treatment attitude is called the main effect. Okay. So, the main effects are called direct effects basically, right. So, there is no interaction or intervention of anything else. But can we conclude that the commercial was ineffective if the, let us say, pre and post difference is 0? Can you claim that the commercial was ineffective? Not necessarily. Why? Maybe the respondents tried to maintain a consistency between their pre and post treatment attitudes. So, you cannot claim that the commercial was ineffective, right. But the main testing effect may also be reactive, causing the respondents to change their attitude simply because these attitudes have been measured. They sometimes the subjects of treatment, they become very sensitive and they take it in a positive or negative manner, and accordingly the results, final results will change, because the sensitivity will have an effect on the final outcome or the effect of the study, right. So, these are to be very careful. So, the testing effects have to be very carefully tested, checked while doing a experiment, right. Now, what is this next thing is the interaction effect. What is this interactive or interaction effect? It says a statistical interaction occurs when the effect of one independent variable on the dependent variable changes depending on the level of the other independent variable. So, what it says, the effect of one independent variable on the dependent variable changes depending on the level of another independent variable. Now, let us continue with the same example. When people were asked to indicate their attitude towards taking a holiday in Egypt, they became more aware of the Egyptian holidays. So, now there were two groups, let us say. So, one group now, or you can say understand that this group only has become more sensitive, they have learnt more about Egyptian holidays, they are aware of it. So, next time when you ask them, so they are sensitized and become more likely to pay attention. Next time when you ask them, they start paying attention and show eagerness towards the subject, right. And because of this, the test commercial that they are shown, they show more interest and they watch it more keenly. So, now the effects will be different, right. Take for an example, you have taken another example I am giving you. So, to measure the interactive effect. For example, let us say you want to see the effect of, I am giving this an example, very different example. Let us say effect of exercise on, let us say, weight loss, right. So, there are two ways we are doing exercise, one is heavy exercise and light exercise, right. So, we can have a study where only the independent variable exercise is having two levels, has an effect on weight loss, right. Now, this is a study which tells about the main effects, but suppose I introduce another variable into the study, which is, let us say, the the diet. Now, vegetarian and non-vegetarian. So, when I am introducing, so now this the person who is a heavy exerciser and who has a vegetarian, taking vegetarian food, and a heavy exerciser who is consuming a non-vegetarian food, for both of them the weight loss would be different. So, this change in weight loss has now happened because of the presence of the other independent variable, that is diet, right. So, that is what it says in an interaction effect. During the main effect, we did not check into any other effects besides the treatment effect, that is the independent variable effect. But here, since there is one more independent variable and the level of this independent variable now is influencing the final result, that is the weight loss. So, then we are saying it is not anymore a direct effect, or it is not a main effect, but it is an interaction effect which is happening due to the interaction between exercise and diet. So, when exercise and diet are interacting or interacting with each other, a new kind of a result is emerging. So, this effect is called an interaction effect. So, whenever a study is, you are doing a study, any researcher is doing a study, he needs to check very clearly the main effect versus the interaction effects. Sometimes the main effects might be very strong, but sometimes the main effects could be very weak, whereas the interaction effects would be very strong, because the, let us say, the only exercise on weight loss might be very insignificant or insignificant effect, right. Say only effect of diet on weight loss could be also insignificant, but if a person takes both diet and exercise together, the effect could be extremely significant, and this is what we say as an interaction effect. So, sometimes interaction effects can be more stronger than the main effect. Well, this is what we are going to do for today. In the next continuing lecture, we will continue with some of the more extraneous variable effects, and we will go further. Thank you so much.